Okay, so remember, when we do factoring, we always want to look for the greatest common factor first. So always look for the GCF. I'm going to factor out that GCF. And then from there, there's three things that we might have. We might have 2 terms, we might have 3 terms, or 4 terms. Thank you. So if we have 2 terms, what we've learned before was it might be a difference of squares. That would mean you had something like a squared minus b squared. And then when we factor that, we make it a plus b times a minus b. And we've done that factoring before. We do have new factoring today for 2 terms. But I'm not going to put the formula up here. We'll just do that in a moment. But it's if we have a sum or a difference of cubes. So that would be if it's 2 terms, you've got 2 things that you could look for. If it is not a difference of squares, it is not a sum or difference of cubes, then it probably doesn't factor. You just leave it. Next is if we have 3 terms. Do you remember what kind of factoring we did when there were 3 terms? Terms are separated by plus or minus signs. So we had 3 terms. How did we factor that? Guess and check. And so we're going to do some of that today. That's where you put the stuff in the 2 parentheses and you guess and then you FOIL it back together to check. And then for factoring 4 terms, does anybody remember that one? It's factor by grouping. If you have forgotten any of these things, then we'll definitely go through examples of all of these today. Right there, grab it. At the bottom, it says always, afterwards, always. Check binomial factors for more factoring. And we will do that lots and lots and lots today, but you always need to go back and check 2 terms to see if they will factor further. And today, a lot of times they will. So you'll get some practice with that. Okay, question A, factor x cubed minus 4x squared minus 5x. What do we do first? Always. The GCF, take out the x, right? So we're going to factor out that x from each term, and we are going to be left with x squared minus 4x minus 5. You factored out the GCF. After you factor out the GCF, how many terms are left in the parentheses?
3.
So we do what? Guess and check. So we bring down the greatest common factor, and we open 2 parentheses for guess and check. Now this has to be x and x. Has to be. To make x squared. What multiplies together to give us negative 5? It could be negative 5 and positive 1. It could be negative 1 and positive 5. But it has to add to give negative 4, so we know it's minus 5 and plus 1. If you're not sure, you FOIL it back together to check. Yeah.
It wouldn't.
It wouldn't work, but those would, yeah, those would multiply together to give you negative 5. So there are 2 choices to make negative 5. Yeah. But those aren't the ones to choose. Yeah. So to check it, you'd multiply back together and make sure it equaled the one above it, which it does. And then we need to make sure that our binomials are factored all the way. So x minus 5, that is a binomial. Is it a difference of squares? It is not. X plus 1, is that a difference of squares? No, this is addition, so this is done. How many x's did we have in the original degree? 3. And then you look here, we have 1x, 1x, and 1x. We still only have 3 x's. Sometimes people create x's that aren't there. That is kind of a check just to make sure if we have 3 in the original, then we have 1, 2, 3 in the answer. All right, question B. Question B, I'm just going to do down here so I don't have room. What do we do first?
GCF.
What is the GCF? 3y to the third. So we put it in front of the parenthesis. We have left over y to the second minus 16. Is that done? These are 2 terms. Is it a difference of perfect squares? Yeah. So we write 3y to the third, and then we have 2 sets of parentheses. And y squared becomes y, and y, 1's plus, 1's minus, and 16 is 4 and 4. Now, are those parentheses factored all the way? Y plus 4, why can I not factor y plus 4? Plus 9. Y minus 4, is that a difference of squares? Is y squared? So, careful. This one is factored all the way. If I look across, I've got 3 y's here, I've got 1 more and 1 more. I've got 5 total y's. In the original question, I had 5 for my degree. I can't have more in the answer than I had to start. All right, question C. What do we do first? GCF, what was it, 5z squared? So we are left with z squared plus 6z plus 9. So how many terms are left over? 3 terms, and it's 3 terms. We factor by guess and check. So I open my parentheses up. What times what makes z squared? Z and z. What times what makes plus 9? Well, 3 and 3 or 1 and 9. But has to add up to equal 6. So we put it in and we check and make sure that that works because I have to FOIL it back together to check. Yes, Brent? I'm going to, yeah. When I FOIL it back together and I actually check my answer, it works. But since these are exactly the same, you write z plus 3 squared. Bless you. You write z plus 3 squared. There are 3, try them on your own. There are 3, try them on your own. Alright, so the student practiced the first one. You should have taken out an x. And you would have gotten x squared minus 7x plus 10. Factor that further to x times x plus 5, or x minus 5 and x minus 2. What if I had the minus 2 first and that minus 5 second? Same thing. It doesn't matter which order the parentheses are, as long as you have the correct signs. The next one, we're going to take out a 3n to the 5th, and you'll have left over n squared minus 25. And so that factors to 3n to the 5th, and then n minus 5, and then plus 5. So it's for difference of squares. And the third one, we're going to take out 8m to the 3rd. And this is where I saw mistakes when I went around and looked at your work. When you take out 8m to the 3rd from the last term, when you take out 8m to the 3rd, we're not subtracting, we're just dividing. So if you divide 8 by 8, it equals 1. So that would give us m squared minus 2m plus 1. And then you factor that further, and it ends up being m minus 1 squared. Missing a few steps on that last one. If I put things on the board that you don't understand how I got them, especially in what we're about to do, you've got to ask right away, because this next thing would be the thing that people usually make the most mistakes on because they don't ask questions. I show you how to do it, and I make it look so easy, and then you try it on your own and you don't understand it. So ask questions as we go. There are formulas, and the formulas are the same for both. I'm only going to look at this formula here, so I have less things to look at. I'm just going to look at this formula and look at the sum of 2 cubes. If we have a cubed plus b cubed, we will always factor it this way. This is a formula. You will find what a and b are and put them in the first parenthesis. Then you will do a squared. You will multiply a and b together, and you will do b squared. The signs will be minus then plus. They will always be that way. Always. So you have a formula, you just follow. Before I do this example, can we just make a quick little list over here of perfect cubes so that you have something to refer to when you do your assignment? What is 1 to the 3rd power? 1. What is 2 to the 3rd? 8. 3 to the 3rd is 27. 4 to the 3rd is 64. 5 to the 3rd is 125. 6 to the 3rd is 216. So you're not writing these down because you have them memorized? And 10 to the 3rd is 1,000. I skipped some in there. You can always use your calculator to check. But if you have this list handy, it makes things go a little faster.
Yeah.
All right. So we're going to factor x cubed minus 125 using the formula that I had circled right above. I'm going to rewrite the formula right here. That's just a formula. So the original is x cubed minus 125. To get the first number or first term, you just have to cube root x cubed. Just say what times what times what makes x cubed. What is that thing? What times what times what is x? Yeah. X times x times x. So we put x here. Now my second term is minus 125. So what times itself is minus 125. You look over here, 5 times 5 times 5 is 125. What makes minus 125? Negative 5. So we put minus 5 here. So then the formula says whatever is in this first spot, square it. So multiply by itself. X times x is x squared. To do the middle spot, it says minus AB. So we do minus, and then we do A times B. Here's our A, here's our B. So we do minus x times negative 5. Then we do plus, and we do B. That's the second spot, that's B. Negative 5 times itself squared. This is what I'm doing in my head. Unless you have to, you can't stare at me and say I'm confused without asking a question. They're both the sum. This is what I said earlier. I'm just going to use this formula. Okay? And if it's different, it will look like this formula when we're done, but I'm just going to use this one because would you like to memorize one formula or two?
Oh, no.
They're not the same though, and people make mistakes. So I'm attempting to have you memorize less. I'm having you memorize one formula. If you want me to go back and do it with cube or the difference, I can. Here, Brandon, let me just change the way the original question was. Is it now sum? Okay, so we're doing sum. Okay. Now all I need to do is simplify what I have here. So I have x minus 5, and then the second parenthesis is x squared, and then when I have minus times a negative, I get plus 5x, and then plus 25. So if you look at the sum of the, or the difference of cubes formula, the signs will match the difference formula if it was originally a difference, but you can do it using the sum. People ask me too many questions about the sign, so if we just do it with the sum, it'll be easier. You won't have to worry about it. Okay, x minus 5, is that a difference of squares that I need to factor further? No. This trinomial, I would need to do by guess and check, but I will tell you, if it comes out of this formula, if it comes out of the difference of cubes or sum of cubes formula, this will never factor further. It will never factor further. You can check it, but it's not going to work. So if you can remember that this one will never factor further, then you know that you're done. All right, let's do another one of these. So the formula is you do a plus b, then a squared minus ab plus b squared. That is always the formula. You just have to find what a and b are first. So you look, oh, I forgot to do something else first though. What is it? What'd I do?
Record.
No, I didn't. No, you were on here saying that. What do I always do for factoring? Is there a TCF?
Yeah.
There is a
You've
TCF.
done
I
that.
got
That's not.
2s squared.
I just wanted.
So I take out that 2s squared. Well, we would have figured it out eventually. And I get 8s to the third plus 27. Okay, so now, because if you try to do this cube formula before, it wouldn't work. So now we're looking at this being the a cubed, and this is the b cubed. So we have to find what a and b are. So 2s plus 3. So we got that by finding what multiplies by itself to give me 8, to give me s cubed, and to give me 27. Just took the cube root. So once you have that first parenthesis, you're just plugging in the formula for the second parenthesis. So the second parenthesis says whatever's in the a spot, whatever's there, multiply by itself. So I do 2s times 2s. 4s squared. In the middle spot, I'm multiplying whatever's in the a and the b spot together and do it with subtraction. 6s. And then in the last spot, I do plus 3 times 3. 9. The first parenthesis that says 2s plus 3, can that be factored further? Is that a perfect square, difference of squares? No. And the second parenthesis I've already told you will never go further. So you can be done.
Oh, it's a student practice.
Yeah, try them. So you got 2 to try. You got 2 to try on your own to see if you understand what we're doing, or ask questions if you do not understand what we're doing. Probably stuff that I can't do. All right. When we have 4 terms, we do factor by grouping. So you're gonna first, you have to put in groups, but when you put the groups in, there has to be a plus sign in between. Plus sign in between, otherwise it means multiply, but that's not what's happening here. So you need that plus sign in between when you put your groups in. I'm going to make some notes off to the side of what we're doing. Then we're going to do the GCF of each group. We're going to factor out the GCF of each group. So the first group, z squared. So I'm going to factor out that z squared. And I'm left with z plus 5. Second group, my GCF is what in the second group? What do you think it is?
Negative.
It is negative.
So that's plus sign is not negative.
Yes. And then that, when I divide out the negative 4, I get z, and then I get a plus 5.
Whoa.
The parentheses have to match. If they don't match, you've done something wrong. You don't just erase them and make them to match, like you go figure out what you did wrong. Parentheses have to match. They have to be the same. If they are the same, then we factor out the parenthesis. We're basically factoring out a big GCF. We're factoring out, we're undistributing it. And it goes in front of a new parenthesis. What is left over in the other parenthesis is what we didn't factor out. So I factored out the group, and I have the other group. So this is factor by grouping that we just did. Now we just have to check it, make sure we factored completely. Z plus 5, does that factor further? Is that a difference of squares or a sum of cubes or something? No, z is to the first power. How about z squared minus 4? Yes, what? Yes, it's a difference of squares. So that becomes z plus 2 and z minus 2. And we check, is z plus 2 factored all the way? If it's to the first power, it's factored all the way. Z minus 2 is to the first power, it's factored all the way. So this would be the answer. Okay? There are 2 student practices. I'm going to work through both of them, but you can work ahead of me if you feel like you got it. I'm just going to work through both of them so they were recorded. But you can work ahead of me if you want. So I'm going to first group them and put a plus sign in between, and then factor out the GCF from each group. Oops. So the second parenthesis, I'm going to factor out a negative 1. If my parentheses match, then I factor out the parenthesis. And I write it in front, x plus 4. And I write it in front of what's left over, x squared minus 1.
Oh, 1's a perfect square.
1 is a perfect square, so that does factor further. X plus 4, x plus 1, and x minus 1. And if you're not sure if you're doing it right, you can look at the very final answer. I have 3 separate x's, and in the original question I have x to the 3rd. So the numbers match. Second one, I'm going to go ahead and group those. Group, group, group. Group, 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 group. Make sure there's a plus sign in between. I'm going to take out my greatest common factor, y squared, and take out a 3 up here. Let's get y squared times 3y plus 1. And 3 times 3y plus 1. So I get 3y plus 1 times y squared plus 3. When I get to this step, 5y squared plus 3, is that a difference of squares?
No,
Why not?
because it's plus.
Right, it's not
Silly
subtraction.
goose.
And because 3 is not a perfect square. 2 answers, 2 reasons why it's not. So then we're done. We only have to go further with that one. Hanging on? Okay. The last section is factoring a polynomial in quadratic form. So what it means by in quadratic form, it's in the form that we've been doing. It just has it's going to be higher exponents. That's the only thing that's going to have a higher exponent in this section. But we do all the same work, just going to have higher exponents. So looking at A, is there a greatest common factor? No. So how many terms does it have? And what are our choices for 2 terms? Difference of squares or perfect cubes? Do we have either of these?
Yeah,
This is a difference of squares, so I'm going to square root, make 1 plus and 1 minus. So when I do the square root of 16x to the 4th, that is 4x squared. And when I do 81, that's 9 and 9. So I did my difference of squares. And then I go back and I say, these exponents are still not 1. Can they be factored further? So this first one, can this be factored further? It has 2 terms. Why not?
it's not difference.
Okay, it's not difference of squares. Is it cubes? Is it sum of cubes? Is it sum of cubes? No. It's squared. So this one is done. What about second one, Alex? The second one is a difference of squares. So one will be plus, one's minus. We'll square root and get 2x and 3. So the second one did go further. All right, question B. What do we do first? Is there a GCF? 3, not just 3. 3p squared. I'm going to go down here. So when I divide that out, I get p to the 6th plus 5p to the 3rd plus 6. All right. So what do we have a trinomial left? We have 3 terms left. So we're going to do guess and check. For the first term, I have p to the 6th. I'm going to split that apart and do p cubed. There is a hint of how to split it apart. If you look in the center. That is telling you, yeah, it's telling you to make it 3 and 3. Then I'm looking at my signs, and they're both positive. So what do I know about my signs?
They're positive.
They've got to be both positive. And what multiplies together to give me 6? 2 and 3 are 1 and 6. And then has to add to give me 5. Okay, so now what do? I go back and see if my binomials can go further. So we've got p to the 3rd plus 2. It's not a difference, neither of these are a difference of squares. But are they cubes? What's the cube root of 2? Are they cubes? They are not perfect cubes. How about 3? Is 3 a perfect cube? Is that on our perfect cube list? No, I just want you to think. So they are not perfect cubes. So they're not difference of squares. They are not perfect cubes. How can I factor them?
Don't.
Right. You just are done. You just are done. You got two. Try them on your own. You got two. You try them. Oh, I was going to help with 8. Just kidding. I forgot. I was going to help with 8. You can try them on your own, but you might get stuck. Oh. Did I not pause it or did I not pause earlier? Or maybe I paused. I know it's going right now. That's good. But I might have paused earlier by accident.
Well, you're gonna have to go back.
No, I'm not going to. So, all right, this one right here. We look at it, and it is 2 terms. Is there a greatest common factor? Okay. Then if it's 2 terms, how am I going to factor that? Difference of squares or cubes? Is this a difference of squares?
No, it's in
Oh, you just. Yes.
Perfect. We're going to go back. We're going to do again, we said. She said, hold on, maybe there is a greatest common factor that I could take out so that I do have a 16n to the 4th minus 625. If I take out that -1, I now have difference of squares. So what's the square root of 16n to the 4th? And the square root of 625. And then from there, y, can 4n squared plus 25 not go further?
It's not difference.
It's not subtraction. How about the second one? Can that go further?
Yeah.
2n plus 5 and 2n minus 5. Okay, we have one last one, and I don't know if the previous one recorded, so I'm just going to do it. You guys can work faster than me if you want to. Is there a greatest common factor? 5w squared. Let's go down here. So I have 5w squared times w to the 4th minus 5w squared plus 6. And that is a trinomial. So I need to do guess and check. And the hint in the middle tells us that we should have w squareds in each spot. But our signs, the second sign means same signs. And then that first sign means they're both negative. So what can multiply together to give me 6? 2 and 3, right?
2 and 3, or 3 and 2.
Good. So now we've got w squared minus 2. Is that a difference of squares? Is 2 a perfect square? Is 2 1 times 1?
1 plus 1.
I didn't ask that. I guess it is times. That is not. How about 3? Is that a perfect square?
No.
So then this would be done.
3 is a prime number.
So it's 2. The assignment is on Big Ideas Online. And it is all what we just did. It's just all factoring. And it follows the order. So you should have your notes handy when you work on it. Get on it, Betsy. You might not have time.